Hi, I'm Ian Nazareth. I'm an architect, academic, and researcher. I am the program manager and head of the Master of Urban Design program at RMIT University in Melbourne, and director of Traffic, a collaborative design practice operating across the domains of architecture and urbanism. I will be presenting with my colleague David Schwarzman. David is an architect at UN Studio in Amsterdam and a researcher and academic at RMIT University. It's great to be here, even if it is virtually, from Melbourne and Rotterdam, to participate in a global discourse on the future of cities. Cities are in a constant state of flux. These anomalous characteristics and behaviors are a product of its interaction with local government policies, market forces, as well as fluctuations in the global dais. These uncertainties make any attempt to intervene within their complex organization rather precarious. Unsuccessful or flailing modernist enterprise, the rise of nation-states, and the unbound exuberance of the free market economy has coincided with the retreat of creative disciplines from the civic realm and public imagination. The increasing decentralized forces, from transformation of workforces, ecological and environmental change to migration, compel a new manner of engagement. However, cities continue to operate within disputed forms of urban renewal and antiquated models of real estate speculation. These conditions call for acute, nimble, tactile responses with overarching strategic foresight. John Gottman first observed transactional forces that stemmed from a labor pool once engaged primarily in the production of goods and tangible products that were rapidly moving to a model of processing and managing intangibles like information and knowledge. Gottman described cities as hosting environments for transactional activities. Access to nodes of hyperconnectivity are a vital force in globalization, as a counterpoint to Thomas Friedman's flat world dictum, which describes the leveling effects of technology on the global scale. Urban theorist Richard Florida observed that from an economic, consumption, and innovation standpoint, the world is spiky, a view that is ratified by the explosive growth of cities, manufacturing hubs, and nodes of service activities.
Transactional urbanism is a projection of a flat, spiky, decentralized city, expressing the significance and influence of ubiquitous transactional exchanges on the form of the city. It presents the techno-social spatial domains that engendered the city. The sharing economy has accelerated the distribution and division of individual transactions, altering the form and order of the city. Sharing is not new. For tens of thousands of years, all living was shared or communal, and through the ages we have shared homes, places of work, and worship. The now ubiquitous term sharing economy, also described as collaborative consumption, is a decentralized platform for commerce and transactions that operates from peer to peer. The cloud, or cloud computing, big data, and an Internet of Things have fueled the planetary digital interconnected platform. The convergence of new communication technologies, energy regimes, renewables, and mobility. An unfolding of a matrix of codependent internets has collectively energized fundamental economic change.
The sharing economy is still a rather ambiguous term, as it is not explicitly sharing, but is focused on monetization. The P2P economy is perhaps unique insofar that it has numerous centralities and terminals of exchange within a decentralized landscape. It is a fundamental variable in how cities and infrastructures are valued and experienced. The P2P economy exposes areas of impunity within the urban system, critical triggers that precipitate in tectonic shifts in cities. The generational swing of renting, leasing, and borrowing rather than possession prioritizes access as opposed to ownership. The focus on underutilized assets suggests the potential for a more efficient pattern of usage and occupation of objects, spaces, and cities. The P2P economy has usurped systems of valuation and value and how value is described and measured. These economies have prompted inventive, if not radical, application of logistical, commercial, spatial, and legal frameworks. Their expeditious uptake has also raised serious regulatory concerns, from confrontations with labor unions, monitoring minimum wage, to safeguarding users and contractors. It is vital to locate the sharing economy adjacent to the concept of smart cities, which will also be a protagonist in the future city, but rooted in a different set of assumptions and aspirations. The smart city has become a symbol and symptom of political change, of aspirational governance shifting one's gaze from space to data and from civic to corporatization. The smart city is incompatible with an informal character of the city, and it reproduces social and urban inequalities. It is more than the movement of data, it is the exchange of capital. Surge pricing is a feature associated with Uber and other ride-sharing services. It's a supply-demand multiplier that exponentially increases the rate at moments of bad weather, rush hour, and special events, at times when large numbers of people want to ride. If we look past profiteering, this demonstrates an almost sentient connection with the city. It senses the city and can actively respond to it. Whether a sporting event or the disruptions to the city's public transport infrastructure, a user-generated dataset mobilizes a heightened response. The sharing economy has inadvertently stumbled on a smart city, one not created by governments or political interests, but by users, subscribers, and citizens. Can this be harnessed for social benefit?
Whilst in contrast, master planning seems hopelessly retrospective in its inability to meet current demands and expectations for social benefit. The sharing economy can be seen to promote the occupation of our cities according to temporal and dynamic user demand and popularity. As disruptive technology operating as a non-physical infrastructure results in its nimbleness, maneuverability, and has an extended temporal dimension in its influence on the city and its change over time. Pattern recognition, a tool employed by sharing economy tech companies, whose underlying motives are unlikely to contain any social agenda, except accidentally, as a byproduct of their quest to remain relevant to citizen needs, could too be a fundamental tool in the repertoire of designers and planners to improve our effectiveness in the future of the city as it unfolds over time. Pattern recognition may help us to conceptualize change and negotiate the complexity evident in the dynamic city system, their insights affording designers and planners to intervene with an extended temporal dimension, allowing for the designs to unfold and remain in play. Cesare Marchetti uses this notion to uncover an underlying operational dynamic, instinctual rules of the game which determine our travel behavior. Whilst Fry Otto's analysis of growth and change in human settlement occupations and their connections provides us with an understanding of the broad human dispositions, inclinations, and rules for which the fabric of our modern city is suspended. Keller Easterling's medium design in a similar way offers an approach to being aware to the chain reactions and interdependencies, patterns of influence and political control, to better understand and influence the matrix of rules and relationships which the city and its forms are suspended. Pattern recognition, medium design, sharing economies, disruptive technologies are all bound by the common feature of temporality. That is to say, they encourage the occupation of space in the city not according to long-term planning rules or a fixed set of criteria, but rather according to ephemeral and temporal user demand and popularity. As cities, just like immune systems, natural systems, or any other complex adaptive system, will not be able to settle into permanent structures, but rather remain in a constant state of adaptation and reconfiguration. Formulations on contemporary urbanism should therefore stem from a necessity in engaging with tools in addressing and responding to the complexity of these temporal urban environments. At a time where conventional urbanism is slow and static, often based on top-down visions and capable of responding to rapidly changing social conditions, the sharing economy has inadvertently stumbled on a smart city, not one created by governments or political interests, but by users, subscribers, and citizens. This, together with new models based on generative computational algorithms, the increasing accessibility and robustness of GIS and real-time city data, allows for a better engagement with the complexity and temporality that urbanism embodies.
Our project Firmware is a design research excursion on the city, approaching digital interfaces as physical environments. Firmware draws reference to a particular class of computer software that provides a standardized operating environment for the device's more complex operations. Without firmware, a hardware device would be non-functional. This analogy of firmware is deployed to focus on the relationship between virtual applications, digital realms, and the physical spaces in the city, as well as the implications they have on the temporal and permanent patterns of occupation, spaces, typologies, etc. It seeks to establish a platform through which virtual and even real-time data can be juxtaposed from multiple sources and spatialized. The furious hive of activity is a methodology. This project is empowered by a process of data scraping whereby georeferenced information and data from web-based application programming interfaces can be extracted into design environments. Here, raw information is co-referenced. The platform is thus a conduit between APIs and computer-aided design applications like Rhinoceros 3D through an algorithmic visual programming language like Grasshopper. The focus is to hybridize disparate datasets from public services and private entities who have a vested interest in the city. This convergence offers architects, planners, and other disciplines an insight into behaviors of cities and networks, all captured through decentralized systems. These can record and reveal patterns and offer new ways of engaging with the city. Using metropolitan Melbourne as a prototype, it can connect open-source city data, city council-specific information, public transport, car park availability, alongside Airbnb listings, Uber movement, etc. Drawing from multiple insular datasets simultaneously, it offers a collective assessment of collaborative consumption. We will briefly talk through 5 projects that stemmed from this. This project proposes the potential for more inclusive features for domestic environments using Airbnb. In the mapping, many thousands of Airbnb listings in Melbourne reveal a pattern of super landlords who own or manage numerous Airbnb properties. We further analyze the city against a functional matrix to understand living, working, and visiting, as well as the patterns and characteristics of Airbnbs in some of these areas. This map outlines the concentration and pricing of these properties. Airbnb occupancy rates became a point of interest, here explored over various periods, events, and seasons, to identify inefficiencies. Melbourne has a high proportion of international university students in the Central Business District, and hence we collated our data with the academic calendar. To see how other uses could be imagined to further augment and amplify the model over the year, through student housing, service apartments, and social housing that could operate through short-term leases. Using the functional mix mapping, these were interpolated with the view on adjacencies and infrastructures of various precincts in the city.
This project harnesses the potential of a hybrid model of transport and commuting. The benefits from the established network of public transport and the flexibility of ride-sharing and Uber. Here, a mapping of the tram network in catchment areas. And a similar idea extended to the train network.
We also study the intensity of Uber's network, where we can see the city expand and contract many times a day. Through getting two datasets, that is Melbourne's public transport network and Uber to communicate, we can select any 2 points within the city and work out the most efficient mode of travel, whether a single mode or a hybrid modality. It can compute overall time and total cost, so an appropriate decision can be made based on a commuter's preference. An extension of this project was to look for nodes of congestion within the CBD, both traffic and parking, and propose a new typology of Uber drop-off zones, hereby catalyzing a new form of urbanism associated with the interchange of goods and services that operate in a temporary time frame of minutes at the very maximum.
This project speculated about a possible symbiotic relationship between the fundamental structures and arrangement of the city and real-time data that determines the transformative and transitory nature of flows of people, products, and capital, proposing a repositioning or perhaps a superpositioning of the hierarchies and the new centralities. Here, generic binaries are replaced by a more dynamic relationship, a spatio-temporal city. Here are mapped 7 domains or criteria from housing affordability, employment, public transport, public open space, and walkability, and the primary determinants in prescribing a livable neighbourhood. These are collected with the relative growth of employment clusters and population density relative to centres. Mobility, whether public transport or private car, is understood in relation to distance travelled, carbon emissions, and finally, block-level energy consumption and floor space usage densities. Considering scale and sprawl as primary combinatory issues in Australian cities that are critical to address, walkability is highlighted, identified, and reassessed as a particular programmatic output, and compared alongside urban green density of pedestrian infrastructures. Finally, the new networks consider how these various uses might in turn determine new morphologies and centralities for the city. These in turn propose strategies for Melbourne's dwelling density target to increase from 15 to 25 dwellings per hectare as an average required to create walkable neighbourhoods. Notably, only 21% of Melbourne suburbs are achieving this even modest dwelling density target. Other virtues include moving towards a 95% policy target for access to public transport, providing access to public open spaces within 400 metres of residencies, and 69% of residencies have access to a bus stop within 400 metres, tram stop within 600 metres, or train station within 800 metres, moving towards State of Victoria's ambitious 95% public transport policy target.
The qualitative attributes of cities are challenged by quantitative criteria and performance measures that produce a range of spurious metrics, rankings, and a standing of livability that seeks to undermine or flatten any differential understanding of the built form or urbanism of a city, potential sameness rather than plurality. This project seeks to unravel this through projecting a temporal lens to understand how cities can be recalibrated to better respond to and establish its own performance criteria. This is closely interrogated through a land use mix, amenities, points of interest, density and its intersections, as well as mobility and safety. Specific points in the CBD become the focus of new cartographies, further exploring more clearly defined comparatives. These include a typological array of facilities, amenities, and infrastructures understood in conjunction with density and floor area ratios within building envelopes. Here we see a mapping of pedestrian activity near transport hubs, trip counts, and modality. These values are equated with accessibility and safety, as well as vehicular traffic, crowding, and intersection densities. These benchmarks become indicators that get prioritized to maximize the benefit of recalibration, and currently under review for design outcomes that are catalyzed by a fine-grained analysis of datascapes.
The unpredictability and complexity of the city system could not be more well epitomized than by its rapid transformation into a pestilential city. This project responds to the physical distancing measures imposed by local government in response to the COVID-19 pandemic and its impact on the function of the city. To understand the extent of the transformation, the city's original patterns of occupation and movement is analysed and mapped against the status quo. The nature of infectious disease and its inherent spatial consequence. The city's spatial carrying capacity here is extracted and spatialised. Proposing spatial and non-physical interventions, this project aims to return the city to its function with minimal disruption, and in doing so highlights the contrast between the city's static physical state and the dynamic social processes and human preferences which it orders.
Through experiences and devices, we absorb space, data, and information in vast proportions. While many experiences are vicariously wrought through encoded and restrictive interfaces, they temper and influence our perception of reality and space. We are also active, sometimes reluctant contributors, patrons feeding the limitless system, fodder for advanced artificial intelligences to process, reconcile, and make intelligible. We know physical from digital, work from leisure, near from remote, city from wilderness, but it could all well be the same, collapsed into a seamless superstructure. The rational morphology of the city is superseded by an arbitrary logic of the temperamental, the real-time, the trending, and yet an exaggerated blur. We are in control, or so it seems. The awareness of our existence is augmented. We have approached the hyperurban.
British architectural critic Cedric Price, who sought to rethink architecture's relationship with society, queried, "Technology is the answer. But what was the question?" as the title of his 1979 lecture. A polemic that remains relevant if not more acute in its post-critical era. Smart cities, data cities, big data and its variants present grand visions for future cities but cannot be deployed through an abstraction of dynamic flows. Information landscapes cannot be easily formalized within the current repertoire. They are, however, a transformative force when deployed through procedural exercises, analytical devices, and strategic, speculative apparatus.
The rapid rise of the peer-to-peer economy has already hinted at how technologies that bypass orthodoxies might be embedded within the cognition of the city, and in equal measure their capacity for disruption. The infrastructures that enable P2P and collaborative consumption could be the pivot for resilience in future urban and architectural form. The future city needs to be adaptable and inclusive. The variants and typologies exist, and the new economic possibilities present a compelling armature. It's a question of capacity and redistribution. Millennials are already entrenched in a hybrid economic system each day. These are all prime variables, and these are futures for local and federal bodies to co-author with P2P platforms to deliver social, economic, and ecological resilience in cities. Thank you.